Hello everyone, could you please tell me if my audio is clear? Please tell me. Yeah, hi everyone. So we are going to continue our discussion today and we'll be solving BARC, especially BARC or PSU level questions for IC engine. In the last class on Saturday, we did power plant engineering. Before that, 2 sessions we did thermodynamics. So in the same series, we are going to continue our discussion on IC engine. Okay. So before we start, let me give you a brief introduction about myself. So as you all know, I have 6+ years of teaching experience for GATE, ESC, AE, JEE, other PSUs. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano, Italy. And I have around 3.5 years of industry and research experience, few research publications. And as you all know already, I have my area of expertise is basic and applied thermodynamics and heat and mass transfer. ठीक है, चलो मेरी ऑडियो वीडियो क्लियर आ रही है तो जस्ट कैन यू जस्ट कंफर्म इट वेरी क्विकली एंड देन विल स्टार्ट. So quick announcement guys, there is a workshop by Anil Prasad sir on 13th. So if you are targeting GATE 2025, what should be your revision strategy? There is a workshop that Anil Prasad sir is taking, so you can attend. This is on the app. Okay, this is on the app at 7:30, so you have to register on the app basically. Also, if you are targeting GATE 2025 and you want to join Vision batches, then there is a scholarship test on 14th of April. 14th of April, there is a scholarship test. You can get up to 90% of scholarship. I think from 10% to 90% of scholarship you will get by taking this scholarship test. Okay, so this test is on 14th of April. You can take it anytime during the day. Online test is there. Okay, chalo. And guys, we are coming on YouTube with this amazing series for you, foundation course. Okay, in which we will be taking subjects. I will be taking thermal. I think it is already started from 11th. So Dheeraj sir will take strength of material. I will take thermal. Chandrasekhar sir will take FM and other subjects as well. Suraj Gopi sir will also take. So completely from scratch. Completely from scratch. So attend this. It is already started. I think evening time is there on YouTube. Okay. So do attend these classes. Chalo. I think we should start. If you have not joined my Telegram channel, do join it. The name is Mechanical by Vipin Yadav. You can either search it or you can scan this QR code. ठीक है? करें start? Yes? करें? Yes? No? Let's start with the very first question. Yes? चलिए. So guys, you have to participate. Okay, otherwise I can just keep going answering and everything. I will not explain simply. Okay, so you have to participate. You have to answer the questions when you see it on your screen, of course. ठीक है? चलो, let's go with the very first question. Select, basically match. You have to match the questions. Okay, so A is 2 isothermal processes and 2 adiabatic processes. I hope that you all know we have 3 isothermal cycles. What are the 3 isothermal cycles? First is Carnot, second is Stirling, third is Ericsson. These cycles are isothermal cycle. Okay, so here isothermal heat addition and isothermal heat rejection takes place. Okay, chalo. So 2 isothermal, 2 adiabatic. What is this cycle? What is this cycle? 2 isothermal, 2 adiabatic. What do you think? And then 2 isothermal is there and 2 isochoric constant volume. Then we have 2 adiabatic and 2 constant volume. That means 2 isentropic, 2 constant volume. And finally we have 2 isentropic and 2 constant pressure. What do you think is the correct answer? What do you think is the correct answer? So isothermal and adiabatic is Carnot. That means A is matching with 3. Okay. Two isothermal, यानी कि isothermal cycles. Either it will be Carnot, it will be Ericsson or Stirling. Two constant volume. So in what cycle we have constant volume? Stirling, यानी कि B is 4. Two isentropic and two constant volume. What is this? Otto cycle C is to 1. And finally, we have two adiabatic and two constant pressure, Breton cycle, Joule cycle, D is 2. What is the correct option? Which one is the correct option? Come on, guys. What is the right option? Option A. Yes? ठीक है, चलें आगे. Yes, A is the correct option. Okay, next is for same compression ratio and heat rejection, which of the following is true? Which of the following is true? If the compression, we have 3 air standard cycles, IC engine cycles, Otto, diesel, dual, and if they all are working at the same compression ratio, they are working at the same compression ratio, then which option is correct? Which efficiency will be highest? So we all know if compression ratio is fixed, then always Otto is highest and diesel is lowest. And in between we have dual. If R is not fixed, if compression ratio is not fixed, then always diesel is highest, Otto is lowest, and in between we have dual. So what is the right answer? What is the right answer? A, B, C, D. Option C. By diesel is the lowest one, Otto is the highest one, in between you have dual cycle. Yes? Correct? Chalo, question number 3. Supercharging in diesel engine is done primarily to supercharging. So what is supercharging basically? Supercharging is increasing the pressure and temperature of the intake air, मतलब intake charge, not just air, whatever charge is coming. So if you are doing supercharging in diesel engine, why do you do supercharging in diesel engine? Why supercharging is done in diesel engine? Supercharging is not done for thermal efficiency. It is done for mechanical efficiency. Okay. We are not doing anything with the heat transfer. Thermal efficiency is what? Thermal efficiency is what is the work output that you are getting out of the heat supply. So we are not improving anything here. We are not dealing with this. What we do is we deal with indicated power and brake power. Sorry, brake power by indicated power. So it is done to improve the mechanical efficiency, not the thermal efficiency. Okay, it is to improve the mechanical efficiency. Okay, chalo. Very simple question, very simple. A diesel engine has a cut-off ratio of 2 and compression ratio of 20. Gamma is 1.4. Calculate air standard efficiency. Now this formula you need to remember, 1 minus 1 upon R, gamma minus 1. Now this is the efficiency of Otto cycle. What you can do is, you can multiply by RC minus 1, divide by RC minus 1, same. And in the numerator, put a gamma here. In the denominator, put a gamma here. That's all. This is the efficiency. Okay. Now you know everything. 1 minus 1 upon 20, 1.4 minus 1. And this is 2, 1.4 minus 1 upon 1.4, 2 minus 1. So you can solve it. 1 minus 20, 0.4. This is given already. This is 2, so it is 1.639 upon 1.4. How much do you get? कितना आ रहा है ये? How much are you going to get? I think you are going to get 0.647, something like this. And the answer is 64.7%. Are you getting the same? I hope that you are getting same. Yes? चलें आगे. चलो. Question number 5. A car has a 4-stroke inline diesel engine whose compression ratio is this, expansion ratio is this. Find out cutoff ratio. So I hope that you remember the relationship. You have to always remember the relationship. Otherwise, if you start driving, then it will take some time. You do not have that time. Compression ratio is equals to expansion ratio into cutoff ratio. Now with this expression, you can find out anything that you want. In this question, you want to find out cutoff ratio. That means compression by expansion ratio. This is 21. This is 10. Answer is, what is the answer? 2.1. 2.1. You need to remember these equations, okay? Otherwise, if you start solving it, it will be an issue. Correct? ठीक है. चलें आगे. Guys, if you are solving it, give me the answer, okay? Give me the answer in the comment box. Otherwise, I would not stop. I'll just keep going. ठीक है? So please answer. Otherwise, why I am like taking the hassle of hassle? Yeah, I think hassle. ठीक है? चलो. At what cut off does the efficiency of diesel cycle approaches that of Otto cycle? So we all know Otto cycle efficiency is 1 minus 1 upon R, gamma minus 1. Diesel cycle is 1 minus 1 upon R, gamma minus 1. Upon, I just now told you, RC minus 1 upon RC minus 1. Numerator में put a gamma here, denominator put a gamma here, and this is your diesel. Now you see, the best option here is not given, because the best option is when cutoff ratio is equals to 1. So you will get diesel cycle efficiency as 1 minus 0 by 0. So you will apply L'Hospital's rule here, and you will get 1 minus 1 upon R, gamma minus 1, which is the efficiency of Otto cycle. But this is not given. This is not given because RC cannot be 1. RC cannot be 1, okay? So now the best option, we have to choose out of what is given to me. The best option I need to choose. The best option here is when you put RC is equals to 0. When you put RC is equals to 0, you are going to get 1 upon gamma R gamma minus 1. So it is basically gamma times more, simply. Okay, it is gamma times, it is almost same as Otto cycle. The only difference is gamma between them. Okay, Here we have a gamma factor. So this will be less and this efficiency will be more. It is gamma times more, but it is almost by 1.4 is what? Almost, 50% more basically. So it is approaching Otto cycle. It is slowly approaching Otto cycle. Okay. If 1 is not given, then 0 is the best answer for you. If 1 is given, then you have to mark 1, because basically they are going to expect that from you. Okay. Chalo. I hope it is clear. Now I hope you all have seen this diagram when we study theory, right? Which of the following represent the correct graph for the relationship between efficiency and compression ratio? So we all know, we have seen this diagram, right? This is how we draw. We do not start with R is equals to 0, because RK is equals to 0 will not work. Compression ratio will be there. Otherwise, engine will not work. Okay. Then after a finite value of 0, this is how the graphs of your efficiency. Here it is gamma, let us say 1.4 or 1.3. Here is equals to gamma is equals to 1.4. Gamma is equals to 1.67. So the value of gamma increases this way and the compression ratio increases this way. So even if you increasing efficiency is equals to 1 minus R, gamma minus 1. When R is increasing, your efficiency is increasing. When gamma is increasing, your efficiency is also increasing. Yes, if you increase, for example, if you fix compression ratio, then this is your efficiency. But if you increase gamma, then your efficiency increases. Okay, clear? So D is the right option. Now the engine based on a standard auto, guys, I hope that you are doing it with me. Yes? Can you give me a yes if you are doing it? A engine based on a standard Otto cycle is operating with air as a medium, with specific heat ratio is 1.4, has a cylinder dia phi is equals to 5 centimeter, stroke length is equals to 7.5 centimeter. Clearance volume is given 88.15 centimeter cube, and heat supplied is equals to 900 kilojoule per kg. Calculate net work output. We have to find out net work output. What do you think we should do? What do you think we should do here? So it's very simple, very simple. We have efficiency formula for Otto is equals to 1 minus 1 upon R, gamma minus 1 is equals to net work by Q in. If somehow I am able to find out R, I can find out, because net work कितना हो जाएगा? Q in 1 minus 1 upon R, gamma minus 1. Gamma I know. This I know. Gamma I know. Only R is required. How do we find R? We know R is equals to 1 plus swept volume by clearance volume. Yes or no? Swept volume by clearance. Now clearance is already given to me. I need to find out swept volume. So 1 plus pi by 4 pi square into L upon clearance volume. So 1 plus pi by 4 5 square. Sir, why are you not changing into centimeter into meters? Because in numerator also you will get cubic centimeter, and this is already given in cubic centimeter. So it does not matter basically. Okay. This is 88.15. कितना आ रहा है R? How much are you getting R? How much R you are getting? So this value is 0.785. I think I have some space. 0.785 into 25 into 7.5 upon 18.15. You will get R. कितना आ रहा है R? So whatever R you are getting, you can put it here. And you will get how much? This is 900. 900. 1 minus 1 upon R. कितना आ रहा है R? How much R you are getting? Because I don't have the value of R. So just write down the value of R. 0.4. And net work, if I remember correctly, you are going to get 291 by 6 kilojoule per kg. Kilojoule per kg. Yes? Are you getting the same? 2.66. Very good. 2.67. Okay. That you can put here. And I think you will get the same efficiency. If I am remember correctly. ठीक है, चलो आगे चलते हैं. क्वेश्चन नंबर 9. In a Otto cycle, air is compressed from this volume to this volume. Okay, from the starting pressure of this, net output per cycle is given. Calculate mean effective pressure. क्या होता है मीन इफेक्टिव प्रेशर? नेट वर्क आउटपुट बाय स्वेप्ट वॉल्यूम. अब स्वेप्ट वॉल्यूम क्या होता है सर आपका? भाई इट वाज 3 liters. Now you compress it to 2.5 liters. So this is your swept volume, which is 3 minus 2.4 liters, which is 0.6 liters, which is 0.6 into 10 to the power minus 3 meter cube. So just write it here. What is the? It is 400 upon 0.6 into 10 to the power minus 3. So whatever you are going to get, you will get in kilopascal. You will get in kilopascal. So it is 400 into 10 to the power 3 by 0.6 kilopascal. Now if I want to convert into megapascal, so it will be 400 by 0.6 megapascal. Because I can multiply it by 10 to the power minus 3. It is kilopascal, right? Megapascal means 10 to the power minus 3. Multiply. So this you can find out how much? Yeah, it is 667 megapascal. Yes. This is the answer. Getting it? Are you getting it? चलो क्वेश्चन नंबर 10. Number of working strokes per minute for a 2-stroke engine cycle as compared to speed of the engine in RPM. As of the speed of the engine in RPM. So it's very simple. I mean, the language looks very tricky, but its question is very simple. Look, one revolution, whenever there is one revolution of, your crankshaft, then it is one working stroke. One working stroke. Right? By in one revolution, we have total 2 strokes, but only one working stroke. Yes or no? One revolution of the crank is equals to, whenever we have one revolution here, so from here to here, 2 processes, then from here to here, 2 processes. So in the entire revolution, we have total 4 processes, but 1 working stroke. 1 working stroke. So in total 1 revolution, we have 1 working stroke. Now it is saying how many working strokes in 1 minute. So 1 working stroke per minute you need to find out in 1 revolution, in 1 RPM, 1 revolution per minute. So basically we have divided both. If 1 revolution has 1 working stroke, so in 1 minute also 1 RPM, 1 revolution per minute is equals to 1 working stroke per minute. Okay. So if there is, basically it is trying to say, if you are making 1 revolution in 1 minute, then you have 1 working stroke in 1 minute. If you are making 10 revolution in 1 minute, then you have 10 working stroke in 1 minute. Simply. Okay, got it? So it is basically same for 2 stroke. For 2 stroke. Okay. For 4 stroke it is half. For 4 stroke it is half. Right? Because in 2 revolutions, for 4 stroke, if you say for 4 strokes in 2 revolutions, you have 1 working stroke. So in 2 revolution per minute is equals to 1 working stroke per minute. So 1 revolution, 1 RPM is equals to 0.5 working stroke per minute. I hope you get this, okay? It is very important. A lot of students remain confused with this for 2 stroke. Got it? Yes. Chalo, same. Because it is asking for 2 stroke. It is asking for 2 stroke, so it is same. If it is 4 stroke, it is half. Which of the following statement is more relevant in the context of IC engine? Basically, which one is correct? It is asking which one is correct. Compression ratio of the fuel air mixture is in the range of 6 to 10 in spark ignition engine. Is it correct? Is it correct? Let's read other statements as well. Compression ratio for air is in the range of 16 to 20 for SI engine. No, it is for CI engine. 16 to 20 is for CI engine. Walls of the engine cylinder of SI engine needs to be thinner because the pressure, the operating pressure or mean effective pressure is lower in SI engine compared to CI engine. So diesel engine, you see, diesel engine when we use in cars or whatever, diesel engines are much bigger, much thicker as well, much bulkier, much heavier. Compression ignition engine have less weight? No, it is higher weight. CI engine have higher weight. So the only option that is correct is A. Yes. आ रहा है समझ में? चलो नेक्स्ट देखते हैं. The function of piston rings in internal combustion engine is also to. Also means what is the other function? But what is the first function? First function is to provide sealing action so that the lubricating oil or your fuel air mixture will not be able to go down the crankcase. That is the first main function of piston rings, to provide a sealing effect. Then what else? Increase the speed? No. Actually, if you increase the speed, it will have more friction basically because piston ring is in contact with cylinder. Prevent piston from corrosion? No, it is not. Cool the cylinder. Cooling cylinder, we use lubricating oil. Dissipate heat to cylinder walls. This is what they do. Why? Because they are in contact with the cylinder walls. So whenever whenever combustion happens, high pressure wave is formed and pushes the piston. So piston gets heated up. Now piston is attached with piston rings. So piston rings take that heat and transmits it out from the cylinder walls. Okay? This is the secondary function. First function is this, provide sealing action. Okay, chalo. What will be the effect? Now this question is asked by many students. What will happen if you mix diesel in petrol engine? And vice versa. But if you have a petrol engine and let us say you work with diesel, then what will happen? Simple answer is it will not work. It will not work. Why? Because diesel, flash point of diesel is much less. Okay, so is much more than petrol. Okay, basically we can see here, like if I have petrol in my hand, or if I spill petrol here on the ground, it will vaporize. So it easily vaporizes. It easily vaporizes. But diesel, if I spill here, it will not vaporize. That means flash point for diesel is higher. So whenever it goes into carburetor, whenever diesel and air goes into carburetor, what happens there? Atomization, vaporization, mixing. But neither atomization will happen, neither vaporization will happen. So mixing will not happen. In the carburetor, we want to atomize, vaporize and mix the fuel with air. But because the flash point is higher, it will not vaporize. So mixing will not happen. And a petrol engine to work, you need a homogeneous mixture of air fuel. But because mixing will not happen, so it will not be a homogeneous mixture. So the fuel will not burn. When it goes into cylinder, it will not burn. Also, because it is in liquid state, it will choke the valve. Because when petrol goes into cylinder, it is in vaporized form, it is in gaseous form. But here, it will go in liquid form. It will not vaporize, so it will choke the valves, piston rings and everything. So basically, it will not let the engine run. It will not let the homogeneous means that air and fuel are mixed properly. So basically, if this is your engine, and you want to mix, you usually put rich mixture. Okay, so let's say you want to mix air and fuel with the ratio of 15:1. That means if one portion of fuel is there, then 15 portion of air should be there. So this ratio will be same everywhere. It will be same here. If you take a sample from here, it will be same here. If you take a sample from here, so air and fuel will be mixed in the same proportion anywhere in the cylinder. Anywhere. ऐसा नहीं है कि if there is a layer here, if at the bottom end of the cylinder, there also air and fuel will be mixed in the ratio of 15:1. But in CI engine, it does not happen. In CI engine, what happens is, if it is CI engine, fuel comes from here. Fuel comes from here. So almost here it is just air. But here fuel and air is mixed. Here fuel and air is mixed. But the proportion is different. Somewhere it is, let us say, 12:1. Somewhere it is 10:1. Somewhere it is 14:1, like this. Okay, so this is called as heterogeneous mixture. CI engine works with heterogeneous mixture. SI engine, this SI engine, it works with homogeneous. And why do you get homogeneous? Because spark plug, in the spark plug, I am saying, in the carburetor, proper mixing of air and fuel happens. Proper mixing by what is the function of carburetor? To give you a homogeneous mixture of air and fuel. So in whatever proportion you need, you mix homogeneously air and fuel and then send it to your engine. But how does mixing happens? It should be in the same phase. Air is in gaseous phase. If your fuel is in liquid phase, it will not mix. So your fuel should also be in gaseous phase. That's why atomization, vaporization, and then mixing happens. But if you send diesel, then diesel will not vaporize. It will not mix. So homogeneous mixture will not form. So combustion will not happen. Okay. So engine will not run. Engine will not run. But if you put petrol in diesel engine, that can work. That can work, but not for long term. Not for long term. Thoda bahut it will start. You will start. The engine will start. You may go like a distance or two, like 1 kilometer, 2 kilometer, then it will stop. Okay, but because it will not be able to provide that much power that a diesel engine requires. Okay, so with petrol in a diesel engine can work. Engine will start. It will work because petrol can burn at that compression ratio. Petrol will burn. So petrol start burning, it will start producing some energy, so your engine will start, but it will not work in long term. But if you are putting diesel, it will not even start. It will not work. Got it? I hope you got it. Okay? You understood homogeneous, heterogeneous? So this is CI engine. It works on heterogeneous. Okay? Chalo. Lo, the next question is, in CI engine, the combustion is what? Combustion is heterogeneous. Homogeneous is what? In SI engine. Homogeneous mixture, homogeneous combustion. Okay? Chalo. Increasing the compression ratio in SI engine, the detonation tendency. So we all know one thing, that in SI engine, whenever temperature or pressure increases for whatever reason, whether you are doing supercharging, whether you are already increasing, whether you are whatever is you are taking in from atmosphere, it is at higher temperature or pressure. So for whatever reason, if the temperature and pressure inside the engine increases, then detonation tendency increases. Why? Because the end charge reaches its self-ignition temperature faster. Okay, but in CI engine, any reason that increases temperature and pressure will reduce the ignition delay period, and detonation tendency will decrease. Okay, and it is saying if in SI engine compression ratio is increasing, if you are increasing compression ratio, that means temperature will increase, pressure will increase, and if temperature and pressure will increase, it will increase the detonation tendency. ठीक है? The knock rating of a SI engine, petrol engine, is determined by matching the performance of engine with which reference fuels? Which reference fuel? Cetane benzene, isooctane normal heptane, cetane and alpha methyl naphthalene, isooctane and alpha methyl naphthalene. What is the answer? Isooctane and normal heptane. So these are the reference fuel for SI engine, and these are the reference fuel for CI engine. Cetane and alpha methyl naphthalene. Okay. Which statement is incorrect with respect to ignition delay period in the diesel engine? So ignition delay period is what? Ignition delay period is when you start the ignition, when you start the injection, so from the point where you start the injection, A is what? Injection starts. and this is B. Here what? Ignition begins. Ignition begins. So this is called as ignition delay period. This is called as ignition delay period. Now let's read the option. Let's read the option. It is saying it is high for high cetane number of fuel. Is it correct? Is it correct? It is not correct. Why it is not correct? Bhaiya, cetane number tells you the ignition quality. So high cetane number means better ignition quality, means low ignition delay. Fuel will burn quickly. Okay. It is the time between injection of diesel into the cylinder and its ignition. This is correct. It is less for low self-ignition temperature. Of course, if a fuel has low self-ignition, then its ignition delay period will be small. It will start igniting sooner. So this is also correct. It depends on the temperature and pressure. Of course, if temperature and pressure is high, ignition delay period will be low. Okay. So this is also correct. They are asking incorrect. So incorrect is the A option. Incorrect is the A option. Yes. Chalo. The self-ignition temperature of diesel. Self-ignition temperature of diesel compared to petrol is. कितना होता है डीजल का? So diesel has around 2110 degree Celsius. Petrol का कितना होता है? How much is for petrol? What is the range? Yes. Is higher. Are you saying A? Petrol is around 250 degrees Celsius. So which one is higher? Which one is higher? Which one is lower? Diesel has a lower self-ignition temperature. And that's why we increase the pressure. Because see, if we use petrol, if you use petrol and you want to increase its pressure to self-ignition temperature, because when you compress it, you want the temperature to reach its self-ignition temperature. So you have to compress much higher than diesel engine, much higher. If you have to compress much higher, why we have to compress much higher? Because its self-ignition temperature is higher. It actually goes to around 300 as well. 280 degrees Celsius, 300 also it goes. I am giving you an approximate figure, 250, but it goes to 280, 300 also. Okay. So you have to keep diesel. For example, you are compressing. Now diesel has reached whatever temperature is there. If you are using diesel as fuel, it is already reached the self-ignition temperature, so ignition can start. But if you are using petrol, you have to compress more. Then it will reach its self-ignition temperature. So you have to compress more in petrol. So if you have to compress more, means pressure is high. Pressure is high means you have to need thicker walls. So if you use petrol with a self-ignition technology, then you need thicker engines, heavier engines, much more heavier than diesel engine. Okay. So the answer is lower. Okay. For a single cylinder 4-stroke oil engine, indicated power is given. Calorific value of fuel is given. And fuel consumption is given. Calculate indicated thermal efficiency. Sir, what is indicated thermal efficiency? Basically, I told you only thermal efficiency is calculated by the heat added. Now, if it is indicated thermal efficiency, then it will be indicated power upon heat input. Okay, indicated power is given 15 kilowatt. How much heat you are adding? Mass flow rate of fuel into calorific value of fuel. So 15 0.001 into 40,000. So it is 15 by 40. So you can calculate how much you are getting. How much you are getting? 15 by 40. 5 by कितना आएगा? B 37.5. Yes, 37.5. ठीक है, चलो क्वेश्चन नंबर 20. डायनमोमीटर इज यूज टू मेजर विच पावर? इंडिकेटेड, ब्रेक या थर्मल? वो इंडिकेटेड ब्रेक या फ्रिक्शनल? विच वन? डायनमोमीटर इज यूज्ड टू मेजर ब्रेक पावर. ब्रेक पावर. Okay, for indicated we use indicator diagram. Indicator diagram. For friction, what do we use? We will see in some time in next few questions. Okay, Wilson's line we can use. है ना? चलो. Now it is giving brake thermal efficiency. You have to calculate of 15 kilowatt IC engine is 30%. So brake thermal efficiency is 0.3. Let us say brake power is 15 kilowatt. Calorific value of fuel is 40,000 kilojoule per kg. Find out mass flow rate of fuel in kg per hour. Very simple question. Brake thermal efficiency is equals to brake power, mass of fuel into calorific value. So mass of fuel is equals to brake power is 15 kilowatt. This is efficiency is 0.3. This is 40,000. Now what you are getting here is kg per second. But they are not asking kg per second. They are asking kg per hour. So you have to multiply it by you are getting this much in per second. How much will you get in per hour? Multiplied by 3600. This much you are getting. Seconds per hour. So now you will get kg per hour. कितना आएगा ये? How much is this? .5 kg per hour. 4.5 kg per hour. Yes. Good afternoon, Ajay. Chalo, last 4 questions. Question number 22. Which of the following devices is used to find the composition of exhaust gas? यानी कि how much is CO2, how much is carbon monoxide, how much is O2, how much is N2? Which apparatus is used to find out these gases in the exhaust gas? The composition of exhaust gas. Which apparatus do you use? Which apparatus do you use? Which apparatus? Use or set apparatus. Or set apparatus. So there are absorbents that absorb a particular gas and you do a volumetric analysis. Volumetric analysis, not bomb calorimeter. No. Or set apparatus. Okay. So there are, like tubes. So it goes in you do volumetric analysis of dry exhaust gases, okay, on dry basis. Okay, chalo. Williams line method, Morse test and motoring test can be done to use which type of power? I told you. Just now I told you. Williams line method, Morse test, motoring test is used to done. Brake power? No, dynamometer test we do. Indicated? No. Indicated diagram. Frictional power, frictional power, frictional power. Yes? Chalo. Second last question, the pyrogallic acid is used to absorb what? It is in Orset apparatus. This is used to absorb what? CO2. Are you saying CO2? Baba, KOH is used to absorb CO2. Then we have copper chloride is used to absorb CO. And finally we have pyrogallic acid to absorb O2. So it is used, this absorbent is used to determine the composition of CO2. This absorbs all the CO that is there. This absorbs O2. Then whatever is left, by balance you can find out nitrogen. Okay, so C. Clear hai? Chalo, let's come to the last question for today. What happens when supercharging is done for a spark ignition engine? I think already answered this during the class, if you were attentive. So if you do supercharging, now what is supercharging? In the beginning I told you, increase the pressure and temperature of the intake charge. Intake charge. Now I already, yes, very good, to increase knocking. I told you already, anything, any process that increases the pressure and temperature, any process that increases the pressure and temperature in SI engine will increase the knocking tendency, So supercharging is not preferred in SI engine, but in CI engine it is very preferred because it reduces knocking. So in CI engine, in diesel engine, supercharging is very well preferred. In SI engine it is not very well preferred. Okay, chalo, very well. So it increases knock. Very good. So this ends, we have done 25 questions from IC engine. This ends today's discussion on IC engine. If you have not joined the Telegram group, do join the Telegram group, Mechanical by Vipin Yadav. You can search by the name or you can just scan the QR code, okay? And you will be able to join. Already guys, our vision batches are started. Gate 2025 and 26. This is already live. So you can join the new batches which are starting very soon. Few batches are already started. Okay. And if you want any help, any guidance regarding, if you have any questions regarding these batches, you can give a call on this number. And you can ask, you can book a one-to-one counseling as well. Or you can just, just ask any questions that you have. There is, in the description box, there is a counseling form as well. So you can just go to the link, fill your details, and you will be called by the counselor. And guys, it is a very structured course. Live classes are going on daily basis. If you miss live classes, you will have access to recorded lectures as well. Study material, you will get entire material you are going to get. Daily practice quizzes you are going to get. And in the end, like in November, December, you will get mock test as well. Okay, everything is included in this. Okay, chalo, very good. So this marks the end of this class, and I will see you tomorrow. We have RAC. What do we have? We have we have refrigeration and air conditioning, and we are going to practice around 25 questions from RAC, BARC level, PSU level questions. Okay, चलो ठीक है, तो I'll see you tomorrow. Thank you very much. Bye bye. ठीक है.